First of all, thank you everyone for being here. I hope you really enjoyed the show. And yeah, just introduce the talk. We're going to see a case study on how me as a developer have been troubleshooting production issues in Cassandra in the last couple of months, right? So hopefully you'll get some insights on what to do or on not, and what not to do as well, right? So yeah, let's make a start. Let's start with some summary, some index. We'll first introduce myself and the company I work for. Then we'll show the problem we are going to see, and well, we are going to see a real life problem we had a couple of months ago, and we are going to do it live, right? So that you see what was the problem, the steps, the exact steps I followed to try to work out what was happening, and all this is going to be live, right? So we will see some code and stuff, and maybe something break, maybe something that, you know, live demos are like this, and then we'll wrap up with some conclusions and questions and answers, right? So first of all, introduce myself. I'm Carlos Alonso. I'm a Spanish Londoner, which means I'm Spanish, which you probably have already guessed by my accent. And Londoner, I live in London, and by my photo you can see that I really miss the beach and the sun, you know. Not very common in London if you happen to go. Well, I got my degree and my master's in Salamanca University, a small city in Spain. Very nice, highly recommended for you guys if you want to go. Nowadays, software engineer at MyDrive Solutions, that I'll speak a bit more later about my company. I'm basically enjoying Cassandra since 2014. That is when I joined my current company, when I joined MyDrive. And since 2 days ago, I'm a certified Cassandra developer, probably. But I actually want to extend this applause to some of other guys that I remember they were in the class with me, and probably they got the certification as well, so please join me. And also, this year I've been given the Data Stacks Cassandra MVP, which I'm really proud of, you know. And well, if you want to know more about me and my stuff, my life and whatever, you can follow me on Twitter or my personal website that you have there, right? Good. About my company. So my company probably is not known at all here in the States. And well, and it's MyDrive Solutions. We do the world leading driver profiling. Well, our product is basically we install black boxes in cars and applications in smartphones, and we collect GPS and accelerometer data as long as the guy is driving the car, right? All of this is time series. I don't know if any of you have heard about this concept in the last couple of days. And we use this data to come with a score on how the guy drives, with some advice like, hey man, if you continue braking on corners, you're probably gonna die young, and this kind of stuff. And also a psychological profile. So the idea is that this information is then given to insurers to adjust somehow the price of your policy, right? So if you are a good driver, this is actually objective risk assessment, right? It is based on your facts and not on the fact that your car is blue or yellow or you are under whatever age or your car has 1,000 horsepower or whatever, right? At MyDrive, we are enjoying Cassandra since 2012, and the company has been recently acquired by the Generali Group, which maybe you know, and maybe you don't. The Generali Group is one of the biggest insurers in Europe, and I think it has very few or no presence at all here in the US. But we have been, well, we are starting negotiations with Progressive, which you probably guys know more than because operates here. Again, if you want to know more, that's the Twitter handle, the website, and pretty much as everyone, we are hiring. So if you fancy what you have heard, you can go on the site, and we are advertising the roles we have, or you can speak to me later on, right? And well, that's about it. Let's introduce a little more the problem we are going to see, right? As the title was of the presentation, we are going to troubleshoot performance issues in production as a developer. So from the point of view of developers, we are a very small company. We don't have any Cassandra administrators on board, right? And outsourcing them is extremely expensive. So we are a couple of developers of Cassandra. And maybe it's not the best approach, but it's what we have right now, right? And then we have a lot of interesting stuff, a lot of banging our heads against walls and these things, you know. And then the good thing of those performance issues is that they happen in production, not in the test environment, right? So we do have a test environment, but for some reason it handles the load properly. And if you want to know a little bit more on this particular problem, it happened on a Friday afternoon. I don't know what's wrong with Friday afternoons, but this problem, these kind of things always happen on Fridays afternoons. I guess that is because then you can go out, get completely drunk, and forget about it. Right? Something like this. So, the program we are going to see, the program is an oversimplification of what we have, right, and of what happened, but more or less we'll do the job, I think. It's basically an import script, right? So we get trips, as I told you, we base our business in people driving, so people make trips, and then we run them through an import script to store them in Cassandra as a time series, right? Yeah, pretty simple. The CSV, so the number of fields as you're going to see, is very normal, nothing strange. So everything should run smoothly as we expect, right? This is our setup. We are going to see two environments, one the production one, another one is the test one. Each of them are 3 nodes clusters. Yeah, it's not the biggest thing in the world, but so far is what we need. And we are using Cassandra 129, which, yeah, I suppose that is a bit too old, but as I told you, we have limited resources. And now that we are so behind, we are really scared on upgrading, right? So it's something that we will have to do slowly and smoothly in the short term, I guess, but it's something. The fact is there, right? Nothing, I cannot avoid it. This is our key space. Pretty simple, again, simple strategy, replication factor of 2 out of the 3 nodes, because otherwise, well, because it's what we have. We could have gone to 3, but we were using 2, right? This is the column family, the table where we are storing the trips. Again, pretty simple. An integer for the driver ID, a timestamp with the end time of the trip, text with the end location, another text with the start location of the trip, and a timestamp with the start time of the trip. For the developers recently certified, I guess that primary key makes sense, right? So all the trips from one driver are collocated in the same node, and furthermore they are sorted by the end time, which I guess makes sense, right? given our use case. And then the rest is pretty much boilerplate. Just we are using size-tier compaction strategy, but I can tell you this had nothing to do with the problem, right? Yeah. Some more tools. Well, by the way, and I don't want to lose half of the audience right now. The demo is going to be in Ruby. Anyone that cannot read Ruby? Well, Ruby is as every language, so I think is intuitive enough to be able to read it and follow it, right? And we will do explanations along the way, so probably, hopefully, no one will get lost on the way. And apart from Ruby, this is I want to describe a couple of tools that we will use in the code. One is Ruby Prof, which is the standard Ruby profiler, right? It's an open source tool. You can see it there in its own GitHub repository. And Casanity, which is a gem that John Newmaker started, and then I become a core committer of it, which is a gem built on top of the Ruby driver that DataStax provides to basically avoid having to write a string CQL all around the place, right? With this, we reduce the complexity and how easy it is to make typo mistakes by using symbols and data structures like arrays, hashes. Well, it's interesting, and if you guys are interested, just you can head to the GitHub repo, right? And yeah, I think that's enough. Let's dive into the code, right? We have it here. It's readable, I hope. So well, this first part, well, this is a Ruby script. These are the required and include arguments, some constants here, and the meat starts here in line 15. So here we are using statsd to monitor all our stuff, right? So well, I hope everyone monitors everything they can. Because this is basically what helped us discovering that we were having a problem. So here we are initiating a connection to my local host statsd server. I'm doing everything local because I don't know you, but in 99% of the conferences I've been, internet just doesn't work. I think this is the first one where internet really works. Big applause for DataStax for this, please. And well, here I take the timestamp where we are starting. We create a Casanity client here with reading with the host where we are connecting to and the port, right? We connect and open the column family we are using. As you can see, we are not using any string here whatsoever, right? Everything comes down to symbols and stuff. And I guess it's pretty readable, so that people that don't know Ruby can follow the explanation. We prepare an insert here, so we are expecting like 10K, 20K trips per CSV, so per run of this script. So it makes sense to prepare the insert beforehand to save those precious milliseconds on every run, right? Again, you can see the syntax of Casanity, how it helps preparing the insert. We define an array where we are going to hold all the features because we are going to go asynchronous, and then simply start parsing our CSV file, and for each record just run an asynchronous insert that then once they are all run, we will wait for them all here, right? this will wait synchronously until this ends, until this finishes, and then we will just take the timestamp of when the whole thing has finished to report the time to to start it, right? I guess it's simple enough. So well, let's run it on our test environment and see how it works, right? So we'll just run it. Well, it's gonna take like 4 or 5 seconds, I suppose. It's inserting like 20,000 rows. So yeah, more or less that did it. For 20,000 rows was, I think, is acceptable. For us, it was acceptable. And if we go to our graphite monitor and we refresh and we render this properly, like this one here, almost 6 seconds, right? We are monitoring as well with Op Center, great tool. We have here 44.94 writes per second. This is going probably to go up right now in the next update. And here in the request latency, we are below 3 milliseconds average. 3 milliseconds, 90th percentile, which is pretty acceptable, I think. And so I think we are good to go, right? We see this, we are good to go to, well, again, also, well, you see now the write requests are coming up, you know, data stack, Op Center takes a little bit to sum up all the data, right? And this utilization is so far invisible, right? So we are good to go. We will now go into sorry. So we are now going to stop our test environment, start up our production environment, and redirect all the stats.d and Cassandra data stacks Op Center to monitor the new one, right? Let's see that everything's working properly. I'm gonna reload this. Well, and this is gonna be fixed now, I guess, once it detects them. No panic yet. Yeah, there you go. So, well, now you see that we are in the production cluster. You can see it here, right? And the data will come soon, right? Good. So, well, so we will start running our script against our production cluster, right? As if, yeah, as expected. So we run it, and it should take more or less the same, about 5 seconds. I guess we are on 4, 5, 6. It's not finishing, right? Well, that finished. Well, let's pretend we didn't show this. Let's just run this again, just in case, you know, maybe the things were tying up them together. 5, 6, 7, 8. But this is getting complicated. As I told you, it's Friday afternoon, and you can see the boss there looking at me. Because he doesn't see this, but he had access to this. And Graphite shows that we have gone up like 3 times. And, well, everything works on test. It's not working on production. So that was our situation. And now what, right? Well, first thing is, first thing that comes to my mind as a developer is, after checking, first of all, checking Op Center, right? well, off center is around the 100 per second here, and although it had a peak here, the mean value is below the 3 milliseconds, which won't add up to the 15, 16 seconds we were seeing, right? So I would discard Cassandra as as what is causing this problem. So I don't know. I'm a bit lost. It's Friday. Yeah, the boss keeps looking at me. So I'm gonna just wrap this code in a profile block, okay, and try to understand where we are losing our time, right? Okay, so for this we are using the Ruby profiler, right? The Ruby prof, and well, to make things quicker, I have a small snippet here to copy and paste to my script, right? Here you go. And just gonna go here. Cool. Let's indent this properly and let's explain to you guys what is going on here. So, what I have done is I have wrapped everything in a Ruby prof profile block that is basically going to keep track of what is going on in the CPU, in the program, in these lines, and then I'm just going to print the results to the console and see if we can get some insight of what the hell is going on, right? So save it, run it again, probably. So it would be nice if this finishes now in 5 seconds, right? But it's not gonna work. It's not gonna be. So it's gonna take again like 15, 16 seconds, and we are going to see a massive trace of the Ruby profiler, right? Good. Here we are. We scroll to the top, which normally is where the most interesting parts are. Yeah, here. So it's spending 100% of the time in the global method, which makes sense because we are in a script, right? 56% of the time, monitor mixing non-synchronized. Not very helpful. I haven't seen such a line in my code. 55, Cassandra feature get. Well, it makes sense because we are running asynchronous, right? Some promises here. I don't want any promise. More promises here. Monitor mixing, thread, condition, mutex. Not very, I don't know. So I'm just gonna say that as the script is very simple, so I'm just parsing a CSV, which is far from slow, and then inserting into inserting into Cassandra. I'm just gonna say that Cassandra is Cassandra's fault, so I'm gonna build a new smaller script with just one insert to this Cassandra column family and see what can I get from there, right? So, well, and this in developer terms is just try to isolate the problem, if that makes sense, right? Well, bear in mind that we are now running this against our production cluster, but when this happened, we just did a copy of the column family to run it in that column family, right? So we are not inserting data in our production cluster just for testing purposes. Again, I have this script here, and to go bare metal as possible, I even removed the Casanity gem I told you before, and now you see how the code becomes a little bit more, well, dirty maybe, because I have to write the literal string that I want to execute, right? So analyzing this script, starts this stuff, and then just create the connection, open the session to the key space, insert, not even asynchronously, we are going to go synchronous right now to try to remove as many variables from the problem as possible, and then get the final timing and submit to Statly, right? Okay, so running this script should be very quick because it's just one insert, and it is not being very quick, which at this moment is a big win because it says that I've been able to reproduce the problem, right? Otherwise, I would have to start looking at other places. So now I can just I'm going to go to the same through the same steps. I'm going to add the profiling block to this one, to that. Now that I have less code, maybe I will be able to understand what's going on, right? So I will add the profiling block to our test script. I guess you guys developers are really used to profiling as well, right? I think it's one of our best tools, at least for me it is. And well, I just need to indent this properly and see what we get. Yeah, come on. Give me something. Okay, good. Scrolling back again to the top, and let's see what we have there. Lots of information. Hopefully something is interesting. Come on. Yeah. No, in fact, this is the wrong. Just go slower. Sorry. There you go. So 100% again in the global. 99.88 monitor mixing, not very useful. 99 Cassandra feature get. Well, this makes sense because we are going synchronous, but under the hoods, the driver goes asynchronous and then waits synchronously for it, right? So that makes sense. We are not crazy yet. Some promises, more promises. Monitor mixing, condition variable, nothing here. Wow. Look at this line, guys. Can you see? So we are wasting 99.4% of our time in connecting to the cluster. So has nothing to do with the insert, which makes sense because we were inserting 20,000 K, now we are inserting just one, and we were seeing the same problem, right? So the problem is actually when connecting, not when inserting. And now what? What can be so wrong with connecting to the cluster, right? So the driver should do it easily. And well, after some thoughts around, I must confess that at this point, I thought about reading on the protocol and capturing the packets using Wireshark and start analyzing them. But thanks God that I didn't do it because that would have been completely crazy. Well, and I also thought, well, probably there's something easier, some stupid thing going on, and well, let's just sit in front of this script a little more and reading the data stacks documentation. I thought, okay, I can maybe add here some debugging, some logging, right? So I can see, because the driver is going to tell me how it's connecting to the cluster, right? So maybe logging information can help me in fixing this problem. Maybe also this is something I should have done at the very beginning of the thing, but well, you know, it's Friday afternoon, the boss keeps looking at me, he's in the end of the hall, I can see him. So yeah, let's create a logger. Here, for example, our logger is logger.new, pointing to the standard output, and we want debug level, right? And we just say add it to the configuration of the cluster, of the connection, right? Logger. Okay, good. Let's see if we know something else. Well, creating connections, did that, this, that, the other. At this point has stopped. So let's mark the line. Come on. Okay. Let's see what was happening just after that line where the thing stopped. I've lost the line, but doesn't matter. I remember it was here, and actually I can see something very interesting, which is host 93, this, that, the other, refused connection. Could not connect to that host within 10 seconds. Wait a moment, because actually 16 minus 6 is actually 10 seconds, right? So this may be pointing to what's happening. So what's happening is that this bad guy here is refusing all connections I'm trying to make him. So why is this? Because I told you that we were running in a 3 nodes cluster, right? And I have here IPs 1, 2, and 3. Why are we connecting to this one? Well, we don't know, but let's see some information on the ring. Okay, so our ring is evenly distributed, well, but has that 3 nodes, exactly. So where is that other node coming from, right? So, well, reading a little bit more on the documentation, I saw that the driver reads on the system peers table for those IPs it is going to connect to. So I'm going to connect to that node and select all from system.peers and see what's there. And ta-da! Here is the bad guy. So, but why is this guy sitting here, right? So, well, who knows everything? Google, right? Let's ask Google. So, wrong IP address system peers assumption. Let's try this way. There you go. I have it tagged. Well, after having a look, hopefully it works, I saw that this is actually a bug in Cassandra. System peers table not updated after the commissioning nodes in 2.0. Well, but we are in 1.2.19, right? In 1.2.9, well, it has been reproducing 1.2.9 as well, right? So what happens here is that at some point in the past, our cluster was 4 nodes, and well, we decommissioned one, and this bug made effect. So every time we are trying to connect, the driver has to wait 10 seconds until considering that node timeout, right? So the fix is really simple. It's just delete from system.peers where peer equals this guy there. Yeah, now it's not there anymore. So now we can run our test again. Wow, that's great, eh? So now we can go and say, okay, run our import the script. So it's 1, 2, 3, 4, 5, 6, 5. Any clue? Any idea?
Do you have to go to the system table of all 3 nodes to delete that guy?
No, not really. Now what is happening is really stupid. It's just that the profiler takes a lot of time, right? So just commenting the profiler lines. But hey, that was a very good guess. Actually, that's something I tried. Well, it's 3 seconds. 4. There you go. Right here we are, and our graphite should be reporting our good time. There you go. We are back where we're expecting. So yeah, actually that made the problem even harder because as you know, the driver spreads the load across all of them, and only one node had this problem. So this problem was happening only when that node was the coordinator, right? So it was even funnier. But I thought that it was enough for this presentation to do it like this. So just to, before we go, conclusions are measure everything, because metrics and monitoring lets us know that we were facing an unexpected performance issue. Keep, very important, this one even more, keep calm and read to the end, because on our files profiling, if I would have done deeper in the stack, I would have seen that the big time of that big percentage is going in the cluster, and I could have avoided writing the extra script and all this stuff, right? So yeah, thanks to the community, thanks especially to Patrick McFadden that we involved in this process from the very beginning, and that's it. Thank you very much, guys. And